Good morning everyone. I am Megha Pandey from Department of Electronics and Telecommunication Engineering. I am going to teach you a subject that is mobile communication, which is one of the subject to final year engineering, electronics and telecommunication. So, I am going to teach you the topic that is known as a cellular concept. Now, whenever we speak about the mobile communication, that means a mobile device is a wireless device. So, it is necessary that there is one base station which is going to cover all the type of user. Now, how much area that particular base station is covering, it depends upon some calculation. For those calculation and for the theoretical version, we consider the area that is covered by the base station to be a hexagonal, that is like this. Suppose this is the hexagonal area, that is the geographical area which is going to cover the number of mobile user. Now, to cover this hexagonal area and all the user, it is necessary that the base station which is having a omnidirectional antenna for the propagation, it should be located in the center of this area as shown in the diagram. So, now we can call this area as a cell, where the area which is shown by this tower we can call it as a base station. Now, this base station is going to cover the users which are in the form of MS, that is nothing but the mobile station, right. So, this is about why we are taking a area in the hexagonal shape and why we call our phone, mobile phone, as a cell phone. Now, here we know that every service provider is allotted a particular band of frequency. For example, you imagine that a service provider is allocated with a band of 33 megahertz. Now, the service provider needs to use this frequency to means a reuse concept, that means within the same frequency the service provider can occupy the more number of user to improve the capacity of system. This type of concept is known as the frequency reuse concept. Now, in this frequency reuse concept, what we are going to do? We are going to continuously reuse the frequency, but there are some limitations of reusing the frequency. The conditions are that very first, two neighboring cells should not have the same frequency. How? I will show you by the diagram. Suppose the cell shown by the hexagon is the cell number A and a neighbor cell of the same shape, that is again the hexagon, is cell B. If the two base stations that are located at the center of cell A and cell B are working on the same frequency, then it may be possible when the users of cell A are communicating and users from cell B are communicating, then there may be an interference which is the unwanted in the mobile communication. So, the requirement is that the two adjacent cells should not use the same frequency. Then how to go for the frequency reuse? There are certain conditions for this. Now, suppose we are going to draw a network of hexagon for this cellular system. It will be like now here to consider the area, suppose this is having the frequency A, we cannot reuse the same frequency within the neighboring cell. So, what will we do? Now, we will take a two integer value, one is the I and another integer value is the j. Suppose the condition is that this integer value should be non-negative. We imagine in this case the value of I is equal to 1 and value of j is equal to 2. In this case, what will we do? If we are using this cell with the frequency A, then from this cell we will go an vertical distance of I value and then we will take an anti-clockwise value of angle and go in the direction of j. Like this, for in this example it is given that I is equal to 1 and j is equal to 2. Therefore, from this frequency we will go straight up to the one cell because I is 1. If in case I is 2, then we can go up to this cell. but in this case the I is 1, so we will go up to this value only, and then for the next value, that is the j value, we will go 60 degree in the anti-clockwise direction, and the value is 2, this one cell and the cell number 2. This cell which is containing the value of I and j, we will reuse the frequency A in that cell. This is the concept of frequency reuse. Due to this concept, there will be no interference because the distance utilization between the two frequencies is more. Okay, so the next part is now after this reuse, we know that a user when in call, it moves from one location to another location, means mobile allows us, it permits us to move from one location to another location. So there is a concept of handoff that we are going to study now. Now in this handoff, again we have to consider the more number of cell. Again the cell size will be, cell shape will be of hexagon. Suppose there are two cells, cell number A and cell number B, right. Cell number A is having a base station, cell number B is also having a base station. Now here what happens, whenever a user is within the cell A and while in call, the user is moving from one location to another location, and suppose the user moves in the cell B. Now when the user moves in cell B, no more cell is in the contact of the base station which is allocated in the cell A. Therefore, if it is the frequency is not changed, then the call may be dropped. So to avoid this type of system, the handoff is there. In handoff, what happens, when a user while in call moves from one cell to another cell, automatically the charge of that cell is given to the another base station. That means now the user is under the coverage of the base station which comes under the cell B, right. So this is the handoff. But again when we talk about the handoff, there are certain schemes that unnecessary handoff should not be given. How to measure that handoff is necessary or not necessary? For that the thing is required, that is the signal strength. Signal strength is nothing but it is the network that we get in our mobile. Generally the signal strength is measured in terms of dBm. The acceptable value to complete a call in the particular power is given by 90 dBm to 100 dBm. Continuously on your mobile, this power is checked. If the received power or the transmitted power is less than 90 dBm or it is less than the range of 90 dBm to 100 dBm, then automatically the base station comes to know that there is a need of handoff. Now the important thing is how to measure the signal strength. There are again various techniques which are going to help us in measuring the signal strength, and that technique we are going to cover now. For the measurement of signal strength, the technique known as RSSI, which means reduced signal strength indicator. This is the one technique. The another technique for the same is and the third technique for this is quality checking. Now the very first technique is the RSSI, that is the reduced signal strength indicator. In this technique, the mobile station continuously checks the signal strength. There are certain devices inside the mobile receiver that helps us to measure the signal strength. If the mobile finds that the signal strength received is less than the range of 90 to 100 dBm, automatically mobile station informs base station that the power strength is reduced and there may arise a need of handoff. The second technique is the word error indicator. In word error indicator, again this type of circuits are inbuilt in the mobile station. the mobile station continuously check for the incoming burst